All right, so this here is what I call chapter 6. There is no part to this chapter, it's just the whole thing, okay? So we're ready to go backwards. You know, it makes good sense that if you were given a velocity function, okay, something in terms of t, we would want to know what the position function was. Or given acceleration, what's velocity and what's position. So one would think that we're going backwards, and we are, because the derivative of s is velocity, right? And the derivative of velocity is what? So now we're going backwards, okay? So we're being actually given, if you want to think of it, we are being given a function, and we have to find a function whose derivative is given. And we said very simply, if I gave to you a derivative, 3x squared, a function whose derivative is that, is what? X cubed. But we said it could be any function, x cubed plus a constant. Okay? Because the derivative of a constant is what? So the answer to this is called the most general antiderivative. It's general because we don't know what that constant is, do we? Do you get that? So that's why we have to put plus c, and that's very critical because it's not just x cubed, it's x cubed plus any constant whose derivative is that. So notationally speaking, how we represent this whole set is by using an indefinite integral symbol. It's like an S, but it's elongated. And you'll see why it's like an elongated S in the next chapter. So if I gave you this, this means the indefinite integral of 3x squared dx. This portion is called the integrand. This is the integral. This is the operator. And this is what is with respect to that dx. A function whose derivative with respect to x is this. So this is the integrand, right here. This is what it's with respect to, the derivative of a function with respect to x that is this. And this is like telling us what to do. Okay? And that would be equal to x cubed plus c. Now we said the important part is the how. How do we get that? Is there a rule for finding such a function? And we said, well, it makes good sense that since we think of it as going backwards, a reverse process, when we take a derivative, we drop the power down and multiply and decrease it by 1. So undoing that would mean we take the power of the function and increase it by 1 and divide by the new what? The new power. So as a rule of the form, right please, this is your power rule, if you will, for antiderivatives. It is the indefinite integral of x to the u power, let's use x to the n, sorry. Okay, dx equals x to the n plus 1 power, divide by that new power, plus c, but there's one thing n can never be yet. And that is a negative 1 power, because increasing with n is negative 1, increasing it by 1 results in a 0, and you know you cannot divide by what? We'll handle that, but not yet to start. So as with derivatives, we need the integrand to be of the form x to the n. X to the n. Individual x to the n's. Because then we can find the antiderivative by increasing the power by 1, add, that is, again, and dividing by the new power. So suppose we have the indefinite integral of x squared plus x cubed over x to the 1/2 dx. You have to create x to the n. As with derivatives, choosing appropriate procedures for derivative calculations, you know you would not do a quotient rule on that. You would use algebra first to create x to the n and then do that power rule. Well, the same thing applies here. What you would have done for derivatives with the power rule is what you're going to do here. You're going to divide first. So it's going to be, what's 2 minus a half? Be careful now. You're subtracting because you're dividing like bases. So that's 4 minus 1 is what? And then 3 minus a half, 6 minus 1 is what? We should have parentheses dx. Now I've got individually x to the n. I could distribute this over a plus or a minus, just like I did with derivatives, but not over a product nor a quotient. You can't do that. So I'm going to increase the powers by 1. You add 2 over 2, get 5 halves, multiply by the reciprocal, which is 2 over 5. To divide by 5 halves means to multiply by the reciprocal. Plus x, add 2 over 2, get 7 halves. Nothing's out here in front. To divide by 7 halves means to multiply by the reciprocal and add c. And you can always check your answer by taking the derivative. So this is a general class of functions. This is a general class whose derivative is this, which would go back into that. Okay? Sound good, everyone? Thank you. Love teaching calculus. 2x squared minus x squared dx. Well, again, we're back to choosing appropriate procedures here. What would we do if that was a derivative? Well, I mean, you could do the chain rule, right? Drop the power down, decrease it by 1, and, multiply by the derivative of the inside, but of course repeating the inside stuff. Or we could use algebra first, where we would get what? Square this is what, gang? 4x to the what? 4. Multiply these, which is what? But double it. And square the what? Last, right? Agreed? And we could always do this. We can distribute the integral over a plus or a minus. You don't have to write that, though. Now you have individually x to the n. Increase the power, so that's x to the 5th over what? 5. Minus, I always do the power first, that makes sense. And 4 over 4 is 1. Plus x cubed over 3, plus what then? I mean, right? We're okay with that? And obviously, you should do the easy simplifies there. All right, what's next? Is suppose we have this. The indefinite integral of x squared times 1 minus 2x squared dx. So, is this x to the nth yet, everyone? So can we create x to the nth? So how are we going to do that? Distribute. So we're going to use algebra what? Never goes away. And then this should be in parentheses. I have x to the n. So what will I do? Increase the power by what? And then just divide by the new power. And of course multiplying by anything out in front. How's that sounding so far, guys? Okay? And some easy stuff that gets missed. The indefinite integral of dx, this is understood to be a 1 there, which is equivalent to x to the 0. When you increase that power by 1, you just get what? X plus c. The indefinite integral of dt is t plus c. The indefinite integral of dy is y plus c, because this is understood to be a 1. Now, even if you have this, simply put, because the simplest things is where you get hung up on. 2 dx, that is 2x plus c, because it's understood to be 2 times x to the 0. You could think of it as. The indefinite integral of pi dx is pi x plus what? C. You got that okay? All right. And next up is this. solving differential equations. So now if we're given f prime of x equals 3x squared, okay? We're going to change that to dy dx because it's the same thing. dy dx is f prime. And now what I'm going to do is I'm going to multiply both sides by dx. By my chain rule for derivatives, dx times dy dx, you could think of these as dropping out, and what's left is dy, 3x squared dx. And what I'm going to come along and do is, after I've separated, notice what I've done there. I was very clever. I separated the y's from the what? X's. So then now what I'm going to do is, I'm going to integrate. Separate and integrate. Say it. Separate and integrate. Separate and integrate. It's like a protest. Separate and integrate. Yes? Separate the variables and integrate. Very important step. The antiderivative of dy, the indefinite integral of dy, is y. Now some students say, well, why don't I put plus c there? You can. But then when you put the plus c here, and another constant over here, and you solve for y, those constants just combine to give you a whole new constant. So there's no need to put a plus c here. Now I increase the power by 1, divide by the new power, and it's x cubed plus c. That's the general function whose derivative is 3x squared. We can find a particular function whose derivative is x cubed and passes through the point 1, 0. Now we can solve for c. And when we solve for c, this is called an initial value problem. What's it called? Because we're given an initial value, which will enable us to solve for c, which gets us to a particular function whose derivative is 3x squared, but passes through the point 1, 0. So I just replace x with 1 and y with what? So what is x? 1. Y is what? And what is c equal, everyone? Do I have it backwards? What is it? Y is 0 and x is 1. Thank you. And what's c then? So now y equals x cubed what? Are you with me on that? Now let's talk about this for a moment. Just watch up here, class, so you understand. And still the derivative is what? But it's the derivative, right, of a function. You know, this is the function is x cubed minus 1. Its derivative is 3x squared, but it's the only function that satisfies the point 0, 1. Because when x is 0 and y is 1, you get 1 equals what? 1. So would this be an answer? X cubed plus 2? No, it's not. No! Its derivative is 3x squared. But does that function satisfy that point? No. So this is not the correct answer. There's only how many now? 1. Here's what you got to think of. Watch. We're going backwards. You know what the shape, just watch, just listen up here. You know what x cubed plus a constant look like in general. This is their general shape. They just go through the, the y-axis. If I elevate it, it's up, positive 1. If it's negative, I drop it down. And you know that. This is now, what happens is, when I come along and draw a bunch of directed line segments, we're getting into this. So I'm not just talking small talk here, to be quick. This here is a bunch of directed line segments. They are the slope of the tangents at several points taken along x cubed. And what I have formed is called a slope field. It's a field of directed line segments. Field of slope of tangent lines at particular x's and y's. When I was at the point 1, 0, which is right here, and I draw and I go with the flow of directed line segments, this is the function, right? It was x cubed, what was it, minus 1? Yeah. This is it right here, so it was dropped down, correct? So this is the function whose derivative was 3x squared and passed through the point 1 what? There it is. How many functions were there? That's right. There were no longer an infinite number. It was just one function whose derivative was 3x squared and passed through the point 1, 0. And how do I find that? I use the initial value. I use what x is and y is to get that. Okay? Alright, so moving on from there is you'll have to watch the remaining of the videos. I'll just do another example. Is the slope along a curve. So here we go. I'm going to do in the other video velocity and acceleration problems. The slope along a curve is 3x minus 2. Find f that passes through the point 1, 2. So we go from, what's written in words to notation. What's now meant when we see slope? dy dx. dy dx means equals 3x minus 2. Yes? We've got to now separate. So you don't have to multiply both sides by dx. Just picture cross multiplying. Putting this over 1 and cross multiplying. And I think we would agree that we get that. Yes? Okay. Now that I've separated, I'm going to come along and what? What's the antiderivative of dy? Now come over here. This is individually x to the n. I'm going to make that 3x squared over what? Minus 2x plus what? And this is where a lot of things break down. We've got to solve for c. X is 1 and y is 2, guys. So 2 is here, and it's just 1, so it's not too bad. If you don't like the fraction, eliminate it. So multiply through by 2. So I'd pick up 4 equals 3, careful, minus 4 plus 2c. That's negative 1, right, guys? Add the 1 and get what then? 5, correct? Divide by 2, and what's c then? And that's the particular function whose derivative is that, and passing through the what? Good. All right, now, write this down. Suppose I tell you, and this is where I'll do more in the video, but there's really not much more to this. I'm going to do a few more examples for you. This homework will be collected, okay, and due, not tomorrow. I'm going to give it to you another day that you can extend it. It's the whole thing, so do half and half. You know what I mean? So you're not overwhelmed. Yes, next homework, the whole thing. Okay? This. Velocity. Velocity is, what's the, well, first of all, guys, let's back up. What do you think is the antiderivative of acceleration? Good, so write that. The antiderivative of this is velocity plus c. The antiderivative of velocity, this would be dt though, would be equal to what? Position. S of t plus c. Excellent. The other way you could represent acceleration is, don't forget, is what? dv dt. So suppose dv dt to be simple equals t squared plus t. Suppose that is acceleration, because that is dv dt. Separate and what? Quizzes are on, though, for Wednesday, that is for sure. They are back. So then now, I'm going to separate and what? So the antiderivative of dv is what? Increase the power by 1. Divide by the new power and put what? Plus c. Then you would solve if I told you what t was, and I have to tell you what velocity was, and resolve for what? Now hold on. Just suppose c came out to be 1. We can find position. The antiderivative of velocity is what? So when you increase this by 1, you get t to the 4th. When you divide by it, you get what? 12, right? Then t cubed over what? 6 plus t. The antiderivative of 1 is t plus what? C. Look up here. The antiderivative of f double prime is what? The antiderivative of f prime is what? F. To be continued. Okay?